If there's one topic that my GRE and GMAT students almost universally struggle with, it's setting up equations and solving them efficiently, particularly with wordy kind of questions. The most common way you'll see this is with age questions. And this video is going to show you how to do this efficiently and confidently. All of the questions will be wordy and the questions will be getting harder and harder as we go along, so see if you can keep up. If you learn anything from this video, please do hit that like button down below and comment as well, and of course subscribe. The first question type that I want to cover, which I've had many requests to cover, is those age kind of questions, where we have to set up an equation involving two people and their age. It's a super common question type on both the GRE and the GMAT, and that's what we're going to cover here. There are tricks to doing it, you just have to remember a couple of things. First, let's get to the question. Genevieve is 5 years older than Mansi. If in 3 years, Genevieve will be twice as old as Mansi, how old is Mansi now? There's a couple of things that I want you to remember. First thing is, people get caught up in trying to have the whole equation ready immediately. And you don't need to do that, as I'll demonstrate. And the second thing to remember is that when we're adding time, for example, in 3 years, you have to add the 3 to both individuals. Because in 3 years, both Genevieve and Mansi will be 3 years older. Those are the two principles to bear in mind, and I'll demonstrate that with this question. Of course, if you want, you can pause the video and try and solve it yourself. Let's now deal with the easier equation. Genevieve is 5 years older than Mansi. Notice the is. Genevieve is. An is like an equals. So we would write G for Genevieve. G equals Genevieve is 5 years older than Mansi. M plus 5. G equals M plus 5. That's the easier one. But now the one people get stuck with. In 3 years' time, Genevieve will be twice as old as Mansi. So what I've written here is not an equation, just Genevieve on one side and Mansi on the other side. And that's the first principle that you can see below. You don't have to write everything at once. Just start with Genevieve. How old will she be in 3 years? She will be G plus 3. How old will Mansi be in 3 years? She will be M plus 3. And now we can get to the equation bit. It says that Genevieve will be, and the will be is like an equals, twice as old as Mansi. So the 2 and then the brackets belongs on Mansi's side. Genevieve will be twice as old as Mansi. So that Genevieve total on the left, G plus 3, will equal 2 brackets the Mansi total, M plus 3, giving you this equation. And that's the hardest step that many students miss. But notice my approach, and we're going to cover this in future questions. I didn't solve the equation immediately or even write out the full equation. I just asked, how old will Genevieve be? G plus 3. How old will Mansi be? M plus 3. And then later on, I'm going to decide who gets the 2. Who gets the 2 in brackets? Because many students would have put the 2 next to Genevieve's side. Because she's twice as old, right? So doesn't she get the 2? But no, translate the equation directly. Genevieve will be, so G equals, or G plus 3 equals, twice as old as Mansi. So 2 times Mansi's total, M plus 3. The 2 belongs with Mansi, even though Genevieve is twice as old. And that gives you our second equation. Because these two equations are relatively simple, we already have G in terms of M. G equals M plus 5. I am going to use the substitution method, which is my least preferred method compared to elimination, and it only works if they've already given you something like G in terms of M. G equals M plus 5. Because then it's very simple to pick up that G and replace it with an n plus 5 in the second equation. Normally, I'll do elimination, as you'll see in future questions. So if g equals n plus 5, we can replace the g in that second equation with n plus 5. What I've done here is quickly expand the brackets first. So g plus 3 equals 2m plus 6 if you expand the brackets. And now I'm going to replace the g with m plus 5. Of course, m plus 5 plus 3 becomes m plus 8. At this point, I would subtract m from both sides. 8 equals 1m plus 6, and then take away 6 from both sides. So m equals 2. If the question had been asking how old is Genevieve, at this point I would have picked up that m equals 2 and placed it back into the first equation. So g, or Genevieve, equals 2 plus 5. So Genevieve is 7. If you have some time in the test, you can then check that you've got it right. 7 is 5 years older than 2, and in 3 years, the 7 will be 10, the 2 will be 5, and that's twice as much. If you don't have time, you just have to trust your algebra. So that was a relatively gentle introduction to setting up these kind of equations. The key thing to remember, number 1, you don't have to write everything at once. You can put Genevieve on one side, then Mansi on the other side, and then later decide who gets the 2, who gets the 1/4, who gets the 5. Second, don't forget to add the time, usually years, to both sides. Notice in 3 years, we put g plus 3 and m plus 3, because they're both 3 years older, and that's how we solved it. Time for a harder example. What about less than, fewer than? And the reason I use this example is many students make mistakes when it comes to less than and fewer than. And I give a quick example down below, but we'll do a harder example on top. 5 apples less than Banks means b minus 5, not 5 minus b. I know the number 5 came first, but we don't write 5 minus b for 5 apples less than Banks. We write b minus 5. And that's something to bear in mind, just because quite a lot of students make that mistake in my experience. I've also written above that would have means equals. We've seen in the last question that is means equals, along with have, has, was. There are many things that translate to equals, and will be. We also saw that meant equals. Let's see if we can apply that to this relatively more difficult question. If Emeril had twice as many sweets as he does, he would have 4 sweets fewer than Udaya. If Emeril had 3 times as many sweets as he does, he would have 5 more sweets than Udaya. How many sweets does Udaya have? Let's deal with the first equation. If Emeril had twice as many sweets as he does, that's relatively easy. That's 2e. He would have, so equals, 2e equals, 4 sweets fewer than Udaya. What is that? Think about it. Not 4 minus u minus 4. 4 sweets fewer than Udaya is u minus 4. Even though the number 4 came first, we write it second. So the equation is 2e equals u minus 4. Can you try and translate that second equation? If Emeril had 3 times as many sweets as he does, he would have 5 more than Udaya. That's relatively easier. 3e again, the would have means equals, and 5 more than Udaya is u plus 5. Of course, when we're adding, it doesn't matter if you wrote 5 plus u or u plus 5, but it's neater to write u plus 5. Now the question is, how many sweets does Udaya have? So we're working out u. Now if we're working out u, we want to eliminate the e's. We just want to know how much Udaya has. We just want to know u, not e. So we're going to eliminate the e's. Now I know what many of you would do. I can almost see you doing it now. You're going to get that first equation and divide by 2. So e equals u minus 4 over 2. And then you're going to sub that into the second equation. But think of all the fractions and the multiplication you're going to have to do to solve that. I just really don't like that substitution method here. I think elimination is far better. But how do we eliminate? Because one of them is 2e and the other one's 3e. Elimination involves making them the same number. So if we want to eliminate the e's, we need that number or coefficient in front of the e to be the same. Can you think of a number that 2 goes into and that 3 goes into? That would be 6. So I'm going to multiply that first equation by 3 to make it 6e, and multiply the second equation by 2 to make it 6e. So the e's are the same, so I can eliminate them. Of course, I can't forget to multiply the entire equation by those numbers respectively. The first equation, if we times by 3, you get 6e equals 3u minus 12, and the second equation, you get 6e equals 2u plus 10. And now that the e's are the same, we can now add or subtract those equations as appropriate to eliminate the e's. Here, the sign in front of the 6e is the same for both of them. We've got positive 6e and positive 6e. So we're going to subtract those two equations. The top equation, take away the bottom equation. 6e take away 6e eliminates the e's and gives us 0. 3u take away 2u leaves us 1u. And minus 12 take away 10 is minus 22. So we have 0 equals u minus 22. And of course, adding 22 to both sides, we know that u, or Udaya, has 22 sweets. Of course, I talked a fair bit, but we're talking about less than a minute to solve quite a complicated question. Notice the two methods. When it was 4 fewer than Udaya, we did u minus 4. We set up both equations and we used elimination by making the e's the same to eliminate them and subtracting the equations because the signs of the 6 e's were the same. I think you are now really warmed up to this topic, so I'm going to throw you the hardest question I can create on setting up and solving equations. I would estimate that at least 90% of my students would be bamboozled by this kind of question, and it would take them ages if they got it right at all. And here is the type of question that I mean. Of course, you can pause the video and try yourself, or wait and listen to my explanation. It's a toughie. It brings everything we've done today together. Let's first read the question, but not get too intimidated by all the complications. Maggie and David have both saved some money. If Maggie gives David $500, she would then have half as many dollars as him. But if David gave 20% of his money to Maggie, he would then have $200 less than Maggie. How much have Maggie and David saved in total? Let's deal with one equation at a time before we get too bamboozled. Let's deal with that first equation. If Maggie gives David $500, she would then have half as many dollars as him. Remember the lesson from the first question. Just have Maggie's total on one side and David's total on the other side. And we can deal with the half as many dollars later. Just have the two totals. If Maggie gives David $500, giving affects both sides as I've written down there. So she would lose $500, but he would gain $500. Don't forget that. So she would be M minus 500 and he would be D plus 500. No equation, just the two totals on each side. Now let's deal with the she would then have half as many dollars as him. The she would then have is an equals and half as many dollars as him belongs on his side. So it would be M minus 500 equals a half D plus 500 in brackets, of course. Don't forget the brackets. The half belongs next to David's side because it was after the equals. It was after the she would then have. Now many of you, because I know you very well, would times out that bracket and have a half D plus 250. No. Let's not have fractions. Let's quickly multiply both sides by 2 to eliminate those fractions and decimals immediately. Don't forget, we hate fractions and decimals. Timesing both sides by 2 we have 2m minus 1000 equals d plus 500. Lovely and smooth. Of course, we can further simplify this by adding 1000 to both sides, getting rid of the negative, and we get 2m equals d plus 1500. Lovely, a lovely simple equation. Let's follow that exact same approach for the second equation. I really think you can do it. You might want to pause the video, think about it, follow the exact same approach in those 4 or 5 steps that we've just done on the left, and see if you can create the second equation. Okay, let's do it. If David gave 20% of his money to Maggie, he loses 20% of his money, but she gains 20% of his money. Let's deal with the equation later and the whole 200 less than later. Let's just focus on how much David has. David has lost 20%, so he's down to 80%. So he only has 0.8d. She, on the other hand, isn't just m anymore, she's m plus 0.2d. So he has 0.8d on the right, and she has m plus the 0.2d that he gave to her. That's not an equation, we've just done 2 different columns with the 2 totals. Now we can deal with it. It says he would then have, so there's an equals in there, 200 less than Maggie. Do we put the 200 first or after? The 200 doesn't go first, even though it was written first. 200 less than Maggie is Maggie's total minus 200. So we have Maggie's total there on the left, minus 200, equals David's total. 200 less than Maggie is Maggie's total minus 200. I know what you're thinking, it looks like a fairly complex equation, but what's our top priority? To get rid of the decimals. And at this point, a simple approach to doing so would be multiplying everything by 10. Do you notice how I always try to get rid of fractions and decimals as soon as possible? Timesing everything by 10, we would have 10m plus 2d minus 2000 equals 8d. And that already looks a lot nicer to me. We could take away 2d from both sides, giving us 10m minus 2000 equals 6d. And now we have a simultaneous equation to solve, and we're going to have to find both m and d because we need to find out how much they have in total. At this point, I'm going to go back to substitution because for the left-hand side equation, it's already expressed as m equals blah, blah, blah. And in that situation, it is easier to substitute. It is 2m rather than just m, but we can multiply that by 5 to get it to be 10m, because then we can just substitute into the other equation. Timesing by 5, we have 10m equals 5d plus 7,500. And that's expressed nice and neatly as just 10m equals. And if 10m equals 5d plus 7,500, we can replace the 10m on the right-hand side with 5d plus 7,500, eliminating the m's. Of course, we can now do 7,500 minus 2,000, giving us 5,500. And we can also, in the same stroke, if you want to be confident, take away 5d from both sides. So 5,500 equals d. At this point, the quickest way to get m is to substitute that back into the easiest equation, which is on the left, 2m equals d plus 1,500. And if d is 5,500, we can add 1,500 to that, which gives us 7,000. 2m equals 7,000, so m is 3,500. I've just subbed it into that equation on the left, the second from bottom, because that's the easiest equation to sub into. M is 3,500, and if D is 5,500, in total they have saved $9,000. That was an epic question because it tested everything. Having 2 different columns without writing the equals just to keep things easier, putting the multiplying factor in the right place, substitution and elimination, and remembering that giving affects both sides, just like time passing does in those age questions. If someone gives 500, they lose 500 and the other person gains 500. If you understood that and got it right, you're prepped for the hardest kind of setting up and solving equations the GRE and the GMAT can give you. I really hope this video gave you an insight into setting up and solving these kind of questions. If it did, of course, hit the like button down below. Have a great day and thanks for watching.